Hi everyone, today I would like to share with you about injection molding. Injection molding is the most commonly used manufacturing process for the fabrication of plastic parts. A wide variety of products are manufactured using injection molding, which vary greatly in their size, complexity, and application. The injection molding process required the use of an injection molding machine, round plastic material, and a mold. The plastic is milled in the injection molding machine and then injected into the mold, where it is cooled and sewn into a final part. The steps in this process are described in great detail in the next session. Step 1, we talk about the mold close. It is more simple application, such as the molding machine close the mold and apply clamp pressure. During the process, the molding machine is monitoring how much pressure it is applying as the safety check. They also may be close profile, where the operator set varying speed as the mold close. In more advanced application, mode we have Asian hydraulic, our mode inside, and underscrew operation. That worker is tandem with the mode close operation. They may operate off time, position, and machinery with the mode. Overall, it is important to find a balance between fast closing time and safety.
Step 2. Injection. After the clamping process, the raw plastic material, usually in the form of pellets, is fed through a hopper into a heated barrel with a reciprocating screw. Inside the barrel, the rotating screw transports the pellet forward the heating bands wrapping around the barrel warm up the plastic pellets. As the pellets are moved forward by the rotating screw, they are gradually melted and are entirely molten when they reach the front of barrel. Once enough molten plastic is in front of screw, the screw injects the molten plastic into the mold cavity through spray and runner system of the mold. Injected into the mold very quickly, and the build-out of pressure pad and holds the material. As the melt enters the mold, the displaced air escapes through vent in the injection pin along the parting line. The amount of material that is ejected is referred to as the choke. Runner, gate, and vent design are important to ensure the mold properly filled. Step 3. Cooling. When the molten plastic is shrinking inside the mold due to cooling, the screw will continuously force the molten plastic into the mold for replenishment to ensure that a complete structure product is produced. The mold temperature controller delivers water or oil into the cooling system to maintain the mold temperature as specified. The molten plastic cools down and solidifies in less than a minute. The mold cannot be opened until the required cooling time has elapsed. The cooling time can be estimated from several thermodynamic properties of the plastic and the maximum wall thickness of the part.
Next is plasticizing the resin. While the part cools, the barrier screw retreats and throw new plastic resin into barrier from the material hopper. The heater bands maintain the needed barrier temperature for the type of resin being used or for proper flow.
The heating bands wrapping around the barrel warm up the plastic pellets. As the pellets are moved forward by the rotating screw, they are gradually melted and are entirely melted when they reach the front of barrel.
Another process is ejection. After sufficient time has passed, the cooked part may be ejected from the mold by the ejection system which is attached to the rear half of the mold. When the mold is opened, a mechanism is used to push the part out of the mold. Force must be applied to eject part because during cooling the part shrink and adheres to the mold. In order to facilitate the ejection of the part, a mold release agent can spray onto the surface of the mold cavity prior to ejection of the material.
The mold opens and the ejector root moves the ejector pin forward. The part and runner fall and are captured in a bin. After that, the whole process repeat over and over to produce more plastic products.
After the injection molding machine's last step, the process continues cycling to create new parts, and periodically the equipment operators or robots separate usable parts from the leftovers runners. The runners is the pathway or runway that the hot plastic takes to fill the mold cavity. Often the runners are ground and recycled to reduce cost and environmental impact. The completed parts are then inspired for quality, weight, size and others, then off to assembly or shipping.
Next, you can see the applications of injection molding. As you can see, the complete shape of chair. This also prepared by injection molding. Then bucket. Next, you can see the CPU cooler that shaped completely. This also prepared by injection molding. Then, these plastic cubes which look very simple but we call having tracks and the neck. It is having a complete shape. It has to be manufactured by injection molding. Then, jugs, ice block tray, helmet, and very importantly, the mobile parts. So, there are many more articles plastic that produced by injection molding.
No, every process or system that we use has its own benefits and harm. It is including this injection molding process that are also have their pros and cons. The advantages that we get from this process are firstly, fast production and highly efficient because it can produce an incredible amount of part per hour, so it is very efficient. Next is it gives the low labor cost, which is the process held automatically and majority of the process is performed by the machine, so we can reduce the labor cost. Third is design flexibility because the molds are subjected to extremely high pressure so that a large amount of detail to be imprinted onto the part. The fourth advantages are it gives the high output production that is allowed. Thousands of parts can be produced before the tooling needs to be maintained. Last but not least, the advantages that can get from this process is large material choices because there is a large selection of polymer resin choices. So, after we know their advantages, we must all know the disadvantages because every process will have at least one harms. For this process, there are disadvantages that they had are high tooling costs and long setups to lead times. It is because the upfront costs are high due to design, testing, and tooling required. They need to do the initial design, then design prototype, mold to produce replicas of the part. And only after extensive testing during both stages, you can finally injection mold a part. Next is part design prescription, which is molding process must follow the basic rules of injection molding, such as avoid undercuts and sharp edges as much as possible. Next, rough angles are encouraged for better demolding. The last disadvantages that we have is small runs of parts can be costly because due to complexity of tooling and the necessity to read the machine of all previous material before the next product can be made. The setup time can be quite lengthy, therefore small parts have traditionally been thought of as too expensive to injection mold.